Chapter 2, Part 3, we are going to start by finding the slope of each of these lines graphed below. So this is number 30A. So we're going to start by making a slope triangle for the 2 points that are given. So we are going to go up 2 units and over 3. So change in y is 2. Change in x is 3. So our slope is going to be, I'm going to say m equals 2/3. Part B, again doing a slope triangle. So we're going to go down 3 units and over 2. So change in y is -3. Change in x is 2. So our slope m is equal to -3/2. Part C, we are not given 2 points, so we're going to find 2 lattice points. So I'm going to pick, here's a point here, 4, 1. That's a nice point, and I'm going to pick the point at -1, -3. So I'm going to make my own slope triangle here. So I'm going up 1, 2, 3, 4 units. So my change in y is 4. My change in x is 1, 2, 3, 4, 5. So my slope, m, is going to be 4/5. Number 31, we're going to graph some lines on this grid. First one for part A, y equals 3/5 x minus 1. So I can identify my y-intercept as -1. So I'm going to plot my point there. And then my slope is 3/5. So I'm going to go up 3 units, 1, 2, 3, and over 5 to the right. 1, 2, 3, 4, 5. And I'm going to put a point. You only need 2 points to draw any line, but I like to continue my points for the whole graph. So I'm going to now go down 3 from -1 and go over 5 to the left. So I have a point over here. And that's all that I have room for. So I'm going to try to draw a nice straight line through my points. And I'm going to label this A. Part B, we want a line with a change in x of 4 and a change of y of -6. And this could be anywhere. So I'm just going to start with a point at +3 for y-intercept. So we have a change in y of -6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. And we're going to go over 4. 1, 2, 3, 4. So I have a point right here. So we're going to go down 6 over 4. 1, 2, 3, 4, 5. So I'm going to run out of space either direction. So I'm going to connect my 2 points with a line. I'm going to try to do this as straight as I possibly can. Woo. And this is going to be labeled B. And again, you could have this line anywhere as long as it has the same slope of down 6 over 4. All right, and then part C, we have f of x equals x minus 7. Remember, that's the same thing as y equals. We're just naming the function. So at -7, I'm going to have a y-intercept point. So right here. And then our slope is 1x. So we're going to go up 1, over 1, up 1, over 1. We can continue to go the whole graph. And we're going to connect them and label D. Oh, I'm sorry, C. This is C. Okay, and then part D, we want a line that has a change of y of 3 and a change of x as 0. So I'm going to just put that, I'm going to put a point right here. So we're going to have a change in y of 3, so we're going to go up 3, 1, 2, 3, but we're not going to go over any. So this is going to be a vertical line. So I'm going to make that D. So which of the lines that you graphed in problem 31 represent a function? If the line does not represent a function, why not? So if we look at our graphs and we do a vertical line test, which I'm going to do in black here, if I draw a line through A, it crosses 1 time. Draw a line through C, it crosses 1 time. B also crosses 1 time. But D is going to cross infinite times. So we can say A, B, and C are functions. D isn't a function. It fails the vertical line test. And to abbreviate vertical line test, I'm going to put VLT. So it does not pass that vertical line test because it is a vertical line. Equations for linear patterns can be written in the form of y equals mx plus b. X and y represent variables, or these unknown values. When you wrote equations relating the figure number to number of tiles, what did x represent? If you remember back in those problems, x was the figure number, and the y was the number of tiles. So m and b, these are called parameters. They're constant values. They do not change within the situation of a given linear pattern. M is also called a coefficient. This is an important vocab word. This is the value that sits in front of a variable, since it multiplies by that variable, x. So m and b represent things just like the tile patterns with the x and the y. So m is going to be, that was our growth factor, how much we were increasing or decreasing. And the b was our starting value. So m has effect on the graph of the line. It tells us the direction of the line, if it's positive or negative, and it also tells us the steepness. So what effect does b have? B is the starting value, which is also called the y-intercept. So I'll say starting value or y-intercept. It tells you where that line is going to cross the y-axis. So number 34, while finding the slope of a line that goes through the points 6, 5, and 3, 7, Gloria figured out that the change in y is -2 and the change in x is 3 without graphing. Explain how Gloria could find the horizontal and vertical distance of the slope triangle without graphing it. So if we look at our points, so we're saying that the change in y is -2, change in x is 3. So looking at our y values, it looks like that Gloria did 5 minus 7 to get -2. And then it looks like she took 6 minus 3 to get 3. So she subtracted them. So Gloria subtracted the x and the y values. So we're going to draw a sketch of the line to validate her method. So we will have a point at 6, 5. Oops. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And there's another point at 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So if we were to connect these, which we will, and we do a slope triangle, she's going down 2 and over 3. So it checks out. So her slope is going to be -2/3. So using Gloria's method without graphing, we want to find the slope of the line that goes through 415 and 211. So I'm going to start with my change in y. So I'm going to do 15 minus 11, which is 4, over my change in x. 4 minus 2, which is 2, which will give us a slope of 2. Using Gloria's method to find the slope of the line that goes through the points 28 and 86, and 34 and 83. So change in y is going to be 86 minus 83, which is 3. Change in x is going to be 28 minus 34, which is going to be -6, which we can reduce to -1/2. Another student found the slope from part D to be 2. What error or errors did the student make? So it doesn't say, we don't have labeled which part is part D, but we're going to take a look back at this part. So if somebody made a mistake and said it was 2, what mistake did they make? So it looks like they flipped the change in y and the change in x. So it looks like they did 6 divided by 3, and they didn't make it negative. So we're going to say slope is not negative, and it is change in y over change in x.